Okay, so that's during mating. Then after mating, there's conflict over fertilization. Oops. And as we've seen during the sperm competition and cryptic female choice, there are various adaptations towards to maximize fertilization. So you have mate guarding, for example. One good example of conflict over mate guarding is in Texas clam shrimps, where you have populations which have males and females, and then you have populations which have hermaphrodites and males. So the males are doing the mate guarding, and if they're mate guarding a female, they will tend to there tends to be more. Let me get this right. If you're mate guarding a hermaphrodite, the hermaphrodite has extra mating opportunities because they can mate with themselves, and so the hermaphrodite doesn't really care so much about how long you mate guard because they've always got the chance of mating with themselves. So males mating with females tend to there tends to be a lot more conflict over the duration of mate guarding. If you anaesthetize the female underneath a male versus the hermaphrodite underneath a male, mate guarding becomes a lot more extended in the populations where the males are mate guarding females rather than hermaphrodites, which is evidence for more conflict over mate guarding duration in populations with male females rather than male hermaphrodites. You have cryptic female choice. We've already met Ornebus, the cricket, where females try to brush off that spermatophore, and males will replace it constantly. That's just one of the tactics. I think we went through quite a few in the sperm competition lecture. But the male Ornebus can replace the spermatophore up to kind of 50 times within a couple of minutes. So he's able to counteract cryptic choice there. And as I said before, you get these weird dynamics with the evolution of nuptial gifts. But when the nuptial gift, what we thought was a nuptial gift is actually a delay tactic to help prolong the male's sperm draining into the female. And then wherever those are lost, so when you have normal mating and a nuptial gift, the cerci on the back end of the bush cricket tend to be just innocuous and small, whereas in taxa that have stopped giving that nuptial gift and kind of removed that delay tactic for the female, the male cerci have evolved into those gin traps, as we saw in the last lecture, and spikes and kind of devices to restrain the female to keep the male in place and prolong copulation for a very long time so that sperm can drain into the female instead of delaying her with a nuptial gift. So that's a good example of sexual conflict after mating. And what we also found in this paper was that we scored species for whether the female resisted the male's attempts to prolong copulation. And what you've got here, I'll just go through this graph. You've got the duration of mating before spermatophore transfer on the y-axis, and the duration of mating after spermatophore transfer when that sperm is draining into the female on the x-axis. And you can see the black ones are where the cerci are modified, so with spikes and traps and all of those things. And the white points here are where there is less modification. And you can see that while there's no particular difference between the black and the white points on the y-axis, there is a large difference in the duration of mating after transfer on the x-axis. So the modified cerci really act to prolong copulation after transfer relative to the duration of mating before transfer. Okay, that's part of the story. But the next part of the story is that, I don't know if you can see, this is just pasted straight from the paper, but the small black points are species where the female doesn't resist very much. And the black points with little circles around them, they probably appear to you as slightly bigger black points. If this is unclear, it might be worth going to the lecture slide on Canvas to see it. But you've got small black points and big black points. And the small black points are slightly further over here, the ones where the females don't resist. So they have longer copulations. And the ones with big black points are slightly further over there, the ones where the females do resist. And so what that shows is that females are effective in reducing, female resistance is effective at reducing copulation duration in the species where the females do resist. So this is, again, a nice example of conflict playing out over the duration of mating after transferring the sperm. Then you have conflict over what females do with their life history. So the female prefers to have lots of different, in many cases, females that have lots of, potentially lots of breeding attempts will prefer to have lots of breeding attempts, and often they'll want to choose which male sires them, represented by different colours here. Whereas any given male mating with that female would much rather she dumped all of her offspring on him and let him sire all of her offspring, and he doesn't give a shit about future matings by that female. He wants her to expend all of her energy, all of her offspring on just him. So there are lots of cases of adaptations, and the key example is those Drosophila, where the male will transfer substances to the female which act to induce her to invest more on this breeding attempt rather than future breeding attempts. And the same thing happens in those sea slugs that do the penis fencing. The darts and the stabbing, the darts that they shoot into each other carry something that the paper calls psychosomatic mucus, which is covered in mucus, which is full of chemicals which act to change the female's life history, make her less likely to mate in future, and make her more likely to produce more eggs at this breeding attempt. The same thing happens in the seed beetles. So kind of extensive kind of chemical conflict over the female's life history. Okay, and finally we have conflict over parental investment. So we've been over quite a few of these. I'm just mentioning them as examples. So there's sexual conflict over the amount of parental investment in biparental systems. If you've got two parents caring for offspring, those wonderful stable strategy negotiation models of incomplete compensation, remember that where each parent compensates only incompletely for the other one, you have conflict over who does more of the work. You also have conflict over who gets to desert and remate. We've met a number of examples. Temminck's stint is one of them, that bird where the males can desert to remate or care for their offspring. A really nice example I haven't mentioned yet is burying beetles. Burying beetles have a biparental care system where they will both care for offspring. But the male typically often is receptive, or the male is often kind of displaying to get more females to come. What they do is they bury a carcass. You can see they're on a little dead mouse here. They'll do is they'll both chew up the dead mouse and bury it in the ground, and then lay eggs on that carcass, and they will progressively chew up the meat and feed it to the babies. It's a very important act to clear up detritus on the forest floor. But if they got a big carcass, then that will support more than one female on the same carcass, and the male will often kind of be displaying and signalling and emitting pheromones to attract more females while he's meant to be caring. And the female will interfere with him doing that, and so she'll knock him over and use behavioural tactics, is how they put it, to stop him signalling to other females, so that you can see in real time there's behavioural conflict over whether or not that male gets to attract a second female to the carcass. There's also conflict over extra pair fertilizations. This almost certainly happens in lots and lots of different passerine birds, but Johnson et al. Did a good study in blue throats where the males have these beautiful, stunning blue and orange throats in the US. And what they did was they painted the throats of some males black to get rid of their sexual signal. And if you paint males' throats black before they've paired, then the black painted males have fewer mates than the controls. If you wait until they've already paired up and then paint their throats black, you find that the black painted males employ more of those behavioural tactics we've been discussing earlier. So they do more mate guarding, they're more aggressive towards their females. They will do less of those tactics which are typical of good quality competitive males. So they'll sing less, for example. But they also lose more of their offspring to cuckoldry. So the female starts shopping around more for other males, for example. So the female manages to escape his mate guarding, and she pays more attention to other males if her own male's throat is painted black. So a good example of kind of conflict once a family is already established, depending upon manipulation of the male's apparent quality.